In this lesson you are going to learn about some basic math vocabulary.
Let's start with the four basic operations: addition, subtraction, multiplication, division. Notice that when doing these operations we say we do additions, we do subtractions, we do multiplications, we do divisions, but we do not say make additions or make subtractions, make multiplications nor make divisions.
When adding two numbers you can say that we are doing additions. Notice that we can say it in different ways. Let's check out some examples. 2 plus 2 is 4. 2 plus 2 equals 4. The sum of 2 plus 2 is 4. 2 and 2 is 4. If you add 2 and 2, you get 4.
Let's do subtractions. 4 minus 2 equals 2. 4, subtract 2 gives 2. 4, deduct 2 gives 2. Take 2 away from 4, gives you 2. Take 2 away from 4, you get 2. Take 2 away from 4, you're left with 2. The difference between 4 and 2 is 2.
Let's do multiplications. 2 times 2 is 4. 2 times 2, that's 4. The product of 2 times 2 is 4. 2 multiplied by 2 is 4. 2 multiplied by 2 gives you 4. If you multiply 2 by 2 you get 4.
Finally, let's do divisions. 4 divided by 2 equals 2. The quotient of 4 divided by 2 gives you 2. The quotient of 4 divided by 2 is 2. The next ones are more unusual. 2 goes into 4 2 times. 5 divided by 2 gives you 2 with a remainder of 1.
Fractions comes next. Look at the picture to the right. The division of two numbers is called the quotient. It is 5/3, but you don't say it like that. You say it's 5/3 and the next one is 1/10, 3/100, etc.
Depending on the result of the division you can get rational or an irrational number. A rational number is when the quotient can be expressed as the fraction of two integers or has a finite number of decimal places or it is periodic. Some examples of rational numbers are 4 divided by 2 equals 2, 1 divided by 2 equals 0.5, 4 divided by 3 equals 0.75. Note that if for example we have 2.33 in English we don't read it as 2.33, instead we say 2.33. The number to the right of the decimal point is a whole number and the numbers to the right of the point are decimals. 1 divided by 3 equals 0.33333.
Irrational numbers cannot be expressed as the ratio of two integers since they have an infinite number of digits after the decimal point, 1.567183906. The decimals are not repeating, thus it's an irrational number. The number pi or 3.14159 is a common example of an irrational number since it has an infinite number of digits after the decimal point. Other irrational number is the square root of 2 equals 1.4121350623704088016887242096980785. Another example is the number e that is sometimes called Euler's number. The base of natural logarithms e equals 2.71828184590452353602887. To prove that they cannot be expressed as the quotient of two integer numbers you use the method of mathematical induction.
Percent. The English word percent comes from the Latin percentum meaning by 100. A percent is another way of representing fractional part of a number. In particular, it is the representation of something out of 100. Examples: 4%, 10%, 50%.
Exponents come next. Look at the picture to the right. X is the base and a is the exponent. When the exponent is 2 we say 3 squared, 4 squared, etc. To generalize we use x squared. When the exponent is 3 we say 4 cubed. When it's another number, we say 5 to the power of 4, 5, 6, etc. In general, we say 3 to the nth power. When the exponent is a fraction, it is a root, y to the 1/3, y to the 3/6, etc.
Let's talk about some statistical terms. When it's everyday talk we say the average, however in the context of statistics, it's the mean. Mean, arithmetic mean, XREM, the median, MDN, the midpoint or number in a distribution having 50% of the scores above it and 50% of the scores below it. The mode, MO, the number that occurs most frequently in a distribution of scores or numbers. In some fields, like education, sample data are often called scores, and the sample mode is known as the modal score.
Standard deviation, SD, the most stable measure of variability. It takes into account each and every score in a normal distribution. This descriptive statistic assesses how far individual scores vary in standard unit lengths from its midpoint of 0. For all normal distributions, 95% of the area is within 1.96 standard deviations of the mean. Variance, SD2, a measure of the dispersion of a set of data points around their mean value. It is a mathematical expectation of the average squared deviations from the mean.
When we want to represent that a number is equal to another we use the equals symbol. When a number is larger or smaller than other, we use the equality and inequality symbols, where the symbol always points to the smaller one. 3 less than 5, 5 greater than 3, x equals y, x greater than equals y, x less than equals y.
There are many more mathematical symbols. In the picture to the right there are some others. Is not equal to, is approximately equal to, approximately, is equivalent to, is identical with, is not identical with, plus or minus.
Geometrical shapes. Let's start with the square. It has a length and height. We can calculate the perimeter adding the length and height and multiplying the result by 2. To calculate the area we multiply the length by the height. For example, the area of a square of 2 by 2 meters is 4 square meters. If we add a width or depth to the length and height, we have a cube. To obtain the volume we multiply the length by the height and width. As in the previous example, a 2 by 2 by 2 cube, we have a volume of 8 cubic meters.
The next shape is the rectangle. It also has length and height but they are different. The perimeter is 2 times the sum of the length plus the height. The area is the product of the length by the height. If we add the width, we get a rectangular prism. To calculate the volume, we multiply the length by the height and then we multiply the result by the width. The point where 3 edges converge is called the vertex.
Another shape is the triangle. It's defined as a closed two-dimensional diagram containing 3 sides, 3 angles and 3 vertices. There are different types of triangles depending on the length of its angles or its sides. Biangles, acute triangle, right triangle, obtuse triangle, bisides, equilateral triangle, isosceles triangle, scalene triangle. According to its angles. An acute angle triangle is a triangle in which all the 3 interior angles are less than 90 degrees. A right triangle is a triangle in which one of the angles is exactly 90 degrees. The hypotenuse is side of a right triangle with the longest length. An obtuse triangle is a triangle in which one of the interior angles is more than 90 degrees. According to its sides. An equilateral triangle has all the 3 sides equal and all 3 interior angles equal too. In this case, each interior angle of an equilateral triangle is 60 degrees. An equilateral triangle is sometimes referred to as an equiangular triangle because all the 3 angles are equal. A scalene triangle is a triangle in which all the sides have different measures and all the interior angles are also different. An isosceles triangle is a triangle in which two sides and two angles are equal. Equal lengths of a triangle are shown by making an arc on each side.
Properties of triangles. A triangle has 3 sides, 3 vertices, and 3 angles. The sum of the 3 interior angles of a triangle is always 180 degrees. The sum of the length of 2 sides of a triangle is always greater than the length of the third side. A triangle with vertices P, Q, and R is denoted as PQR. The area of a triangle is equal to half of the product of its base and height.
If we add a third dimension to a triangle, we get a prism. There are different types of triangular prisms because they depend on the type of triangle its base is.
Now we have the circle. The distance around a rectangle or a square is, as you might remember, called the perimeter. The distance around a circle, on the other hand, is called the circumference, c. Half of the diameter, or the distance from the midpoint to the circle border, is called the radius of the circle, r.
A circle in 3 dimensions is a sphere.
Another shape is the ellipse. Look at the picture to the right to learn about the formulas.
Cone. A cone is a 3-dimensional object that has a circular base joined to a point by a curved side. The point is called a vertex. The cones have height, the slant height and the radius.
Rhombus. A rhombus is a parallelogram in which adjacent sides are equal. The diagonals of a rhombus bisect each other as it is a parallelogram, but they are also perpendicular to each other.
Finally, but not least, let's take a look at the XY grid. The coordinate plane was developed centuries ago and refined by the French mathematician René Descartes. In his honor, the system is sometimes called the Cartesian coordinate system. The coordinate plane can be used to plot points and graph lines. This system allows us to describe algebraic relationships in a visual sense, and also helps us create and interpret algebraic concepts. The horizontal axis in the coordinate plane is called the x-axis. The vertical axis is called the y-axis. The point at which the 2 axes intersect is called the origin. The origin is at 0 on the x-axis and 0 on the y-axis. The intersecting x and y-axes divide the coordinate plane into 4 sections. These 4 sections are called quadrants. Quadrants are named using the Roman numerals 1, 2, 3, and 4, beginning with the top right quadrant and moving counterclockwise. Locations on the coordinate plane are described as ordered pairs. An ordered pair tells you the location of a point by relating the point's location along the x-axis, the first value of the ordered pair, and along the y-axis, the second value of the ordered pair. In an ordered pair, such as x, y, the first value is called the x-coordinate and the second value is the y-coordinate. Note that the x-coordinate is listed before the y-coordinate. Since the origin has an x-coordinate of 0 and a y-coordinate of 0, its ordered pair is written 0, 0. Look at the picture to the right.
That's it for this lesson. See you in our next hands-on the English Flipped Classroom session.